let's do some guided practice. These are a little bit more the speed at which I would ask you to do a quiz or an exam problem, right? A polynomial. So let's take a look. Find all the first derivative and second derivative information. Okay. So for this one, we're just going to do dy over dx. We're going to get x squared plus 4x minus 5 equals 0. Maybe I should write let this equal 0. Well, that's going to imply that x plus 5 times x minus 1 equals 0. And that, of course, implies that x equals negative 5 and positive 1. Okay. So those are going to be our critical numbers. Now, I guess note that we're not actually classifying whether they're maxes or min. So it's kind of nice. So I guess we can just say y has crit points 5 and y of negative 5, because I'm not going to do that out. And 1 f of 1. Okay, those are our critical points. Our intervals of increase, well, I guess we ought to do that out, right? Get a little chart going. You know what? Let's wait. Let's do the second derivative first, right? So now we're going to let d squared y over dx squared, right? Take the second derivative, which is just 2x plus 4 equals 0, right? So here x has to equal negative 2. Now we can draw our interval chart, and now we're going to be fine because we're going to have all of our information, right? So negative 5 and 1. And negative 2 is actually right in between them, right? So let's see what we're getting. Intervals of increase. Let's plug in a low negative, like negative 6 in here. We get negative, negative. That's going to give us a positive. Plug in 0 in for the derivative. You'll see that gives us a negative. And then plug in a big positive number. You'll see that gives us a positive number. Into f prime, that might be a little bit easier to see. We get that. So let's just write our answer down. We wrote down the crit points already. F is increasing on negative infinity. It's negative 5, union 1 to infinity. And decreasing on negative 5 to 1. F is concave down on negative infinity. It's negative infinity and negative 2. And concave up on negative 2 to infinity with inflection point negative 2 comma f of negative 2. I'm not going to plug that in. Okay. Now if we take a look at this guy, number 2, this one maybe is a little not so bad. We should be able to plug in our numbers and be able to simplify that no problem. Right, so again, we're going to let the derivative equal 0. Right, times 1 because of the chain rule, whatever. Let that equal 0. It's going to imply that 3 times x squared minus 6x plus 9 equals 0. Actually, why am I even doing that? I shouldn't even do that. What's wrong with me? Don't even factor it out. We already have our answer. X equals 3, right? And now, before we even do anything else, let the second derivative, which is this, equals 0. Again, x equals 3. So kind of an interesting function here, right? If we were to draw this interval chart, it's not going to be the most exciting in a sense. Maybe I should call this y prime and y double prime, whatever. Right? All it's going to be is 3 and 3, right? That's it, right? And I think we can see here, well, there's an obvious, yeah, I think you can see this, right? We're actually going to have, because it's being squared right here, the derivative is positive before and after 3. Whereas the second derivative, if you plug in a value less than 3, you get negative, and then it's positive, right? So again, now we just write out our stuff, right? We just say y has critical points, or just has critical point, right? 3, comma 0, and is increasing on really everywhere except 3. Right, because 3 was a critical number. Right, never decreasing. Maybe I should just say y is concave down on negative infinity to 3, and concave up on 3 to infinity. And I believe there's an inflection point, right? 3 comma 0 is actually not just a critical point, but it's an inflection point.